Today we're going to be looking at another one of NileRed's videos, specifically the heavily requested making bulletproof wood video. For those of you who don't know me, I'm Tyler Folse. I'm a nuclear engineer with a little over 10 years of experience in the commercial nuclear power industry, from engineering to operations to emergency response. I don't claim to know everything there is nuclear, but I can certainly share some knowledge. Let's get right into it.
I stumbled onto this paper published in Nature, and it was called Processing Bulk Natural Wood into a high-performance structural material.
Cool.
From this title alone, it didn't sound too spectacular, but the results were actually really impressive, and they were apparently able to make pieces of wood, which were by weight, stronger than steel.
That's impressive. Wonder if it would have any potential applications in a nuclear power plant.
It was just a quick comment, but they suggested that with their super strong wood, it'd be possible to make lightweight and low-cost armor, or in other words, bulletproof wood. Up until this point, the idea of using wood to block bullets had honestly never even occurred to me, but the moment that I saw this, I felt that I had to try making some.
Make it thick enough, sure. Haven't done much with bullets, but you do a lot in nuclear engineering looking at shielding from radiation. And a lot of the same principles apply, though bullets you're talking about a strictly ballistic force versus radiation, which can pass through certain materials depending on what it's made out of. So radiation's a lot more material dependent. Though there are some similarities, as in you have a neutron going through a mile of concrete versus a mile of paper, it's still going to get stopped. But within reason.
The only tricky part was that, again, the idea of wooden armor was only a suggestion they made based on some small-scale tests, and they never actually tried to stop a bullet with it.
I mean, wooden armor did exist briefly before metal armor, though I wonder if it ever existed at the same time guns were used among the people that used wooden armor. Wouldn't think so, but for those of you who are historians, let me know.
And I figured there was only one way to find out. All I had to do was two basic steps. One was to treat almost any kind of wood using some commonly available chemicals, and then after that, I just had to squish it and heat it.
This diagram is amazing. Arrow, chemicals, squish it and heat it. I gotta love it. I admire some level of simplicity. I mean, it's no different than how a nuclear power plant works. Hot rocks make steam, spin roundy thing that makes zappy things. There you go.
Supposed to leave me with a really dense and strong piece of wood that was roughly a fifth of the thickness of the original piece. The only problem was that even though it seemed really simple, I didn't really know exactly how to do it. I mean, for the first part, I was totally fine, and I had everything that was needed to treat some wood with some chemicals. The second part was the issue, though, because I had no idea how I was supposed to evenly crush a piece of wood while heating it at the same time. To do this, I figured that I was going to need some sort of press thing, and my first thought was to get something like a panini press and to stack a bunch of weight onto it.
That looks amazing. I mean, you heat wood enough, you're gonna just boil away all the water, because it consists of dead plants, which, like a lot of life forms, are mostly water. On that note, wood would actually make a somewhat effective material at absorbing neutrons, at shielding from neutrons, but you're just going to need so much of it compared to even concrete. And what slows down the neutrons is the water, the hydrogenous material. So water by itself, used in the reactor coolant system, works, as well as the concrete in the reactor containment building will keep the neutron radiation in. If you lose the reactor coolant system, the plant shuts itself down pretty quickly because water is used as a moderator to slow down the neutrons. You lose that, it's not going to be a sustained nuclear reaction. Water, concrete, better neutron shieldings. Also helps that they're less of a fire hazard.
However, I then converted the 5 megapascals that the paper said I needed into a unit that I could actually understand, and it was apparently 725 pounds.
I love that. Oh, metric system users, eat your heart out. I have to say, though, I'm used to PSI as well. Of course, granted, working at a nuclear plant in the US, units like PSI, degrees Fahrenheit. I have a bit more of natural affinity for the degrees Fahrenheit to degrees Celsius conversion compared to converting megapascals to PSI. I mean, yeah, I can do it, but it's just more of a... I'm so much more used to PSI than I am used to megapascal, so I hear you.
Square inch. This meant that even for a small piece of wood, I'd have to stack
some more weights.
Of pounds onto it.
Yep.
Which I felt would be slightly difficult.
Yeah.
It was pretty clear that I was going to have to use some sort of machine that was actually designed to heat and crush at high pressures.
I love this planning phase of NileRed's videos. Like, note that powerful is bold and underlined, and cook and crush are bold, underline, red, and in all caps. These are important, and there's a whole science behind writing procedures of doing these little font things so they are more recognizable by the users. I mean, yeah, this isn't a procedure, but that's what this reminds me of.
And I decided to try looking online. I found what actually looked like the perfect machine. It had some nice stainless steel plates, which could easily resist the chemicals. It could crush with even more pressure, and it could do around 60,000 pounds of force, and it had some easy-to-use temperature controllers. Final quote that I got, at the time, this was also significantly more than I'd ever spent on any project, and the thought of paying that much on an idea that might not even work made me really uncomfortable. I decided to ignore all logic and reasoning, though, and $5,000, and a few months later, I was the proud owner of an extremely heavy wooden box.
Wow.
I was actually kind of surprised by just how heavy it was, and I was slightly worried that I wasn't going to be able to move it.
Maybe somebody else already made the bulletproof wood and put the device in the bulletproof wood. Nah.
So I went and got a knife, and I started by cutting off all the plastic strapping.
This is doubling as an unboxing video. This is pretty good.
I then started flipping up all the metal tabs that were holding down the top of the crate, and after that, I slowly opened it and revealed my beautiful little press. I then carefully broke apart the rest of the crate.
Carefully.
And I got rid of all the plastic and the accessories.
Vent your frustration.
Reggie and I also snapped our backs, transferring this 400-pound hunk of metal to a dolly, and at this point, I was starting to get really excited. To get started with this, the first thing that I needed was some wood. I decided to go with pine though, because it seemed to give some really good results, and it was also by far the cheapest and easiest to get. All I had to do was quickly go to Home Depot, and for around $20, I picked up one of the nicest pieces that I could find. I then did some quick measurements, and I started chopping it up, and my goal was to get some pieces that were roughly 12 centimeters long. I then quickly sanded them to clean them up a bit, and now my wood was ready to be cooked. So I went and got a 1 liter.
This looks like a bigger block for your Jenga set. That would be something, playing Jenga with something made out of bulletproof wood.
And I started by pouring in about 600 mils of water. I then turned on the stirring, and when I had a strong vortex going, I dumped in 80 grams of sodium hydroxide drain cleaner. When it looked more or less clear, I then got this sodium sulfite that I bought on Amazon, which was apparently supposed to be used to cure salmon eggs. I wasn't exactly sure what that meant, but either way, I just dumped in 40.3 grams of it, and just like the drain cleaner, I waited for it to dissolve. So I carefully lowered in one of the pieces, and while holding it in place, I added more water until it got to the 1 liter mark. After that, I put a heavy watch glass on top of it to push it back down into the water, and what I had to do next was get it nice and hot. So I turned on the hot plate and waited for it to heat up, and over the next 20 minutes,
doesn't need it to be.
It slowly got more and more yellow. I then came back to it a couple hours later, and it had become a dark orange, and things seemed to be going well. They included a super close-up shot that's looking down the end grain of a generic untreated piece of wood. This, on the other hand, was what it looked like after they treated it, and there was a pretty big difference. This was supposed to make the wood a lot easier to squish, and this was very important for the next step.
I guess that makes sense about any sort of material that you're going to make. Looks like it's going to make something with a lot more tensile strength.
So I just quickly got rid of this hot red chemical solution, and then into the same beaker, I started dumping in a bunch of boiling distilled water. The goal here was to get rid of as much of the sodium hydroxide and sodium sulfite as possible, and to also wash away any side products that might have formed. A lot of these chemicals and side products were deep inside the wood though, so I had to soak it for a while. The only unfortunate part was that the paper didn't say for how long, and all it said was that I had to immerse it in boiling water several times. I assumed that this meant more than just quickly dunking it in and out, and based on almost nothing, I decided that about an hour was a good time. So I just left it there.
It's always interesting when you get a procedure and set of instructions that don't specify how long you do something. I mean, this is some old piece of reference material he's going with. So yeah, you just have to try it and see what happens. And procedures from like the early days of starting up nuclear plants, they ran into this just a lot. And can imagine trying to do something like that and kind of going with the equivalent of your grandma's cooking instructions. Just let it sit here for a little bit, or a good little bit, or a pretty good little bit.
And over the next hour, the color of the water slowly changed, and I felt this was a good sign because it meant that it was pulling stuff from the wood. After about 15 hours of cooking and cleaning wood, I was finally done the first part of the process. It really just felt like a generic piece of wood that had been sitting in hot water, and it didn't feel like there was any major difference. So now, it was finally time to test out my new and beautiful hydraulic press, and the first step was to turn on the temperature controllers. I did my best to make it as centered as possible, and when I felt that it looked good, I started lowering down the upper plate. It was a bit slow and clunky, but I was eventually able to sandwich the wood.
Not like your nice, smooth, soft hydraulic press where it just slowly but deliberately goes in. Yeah, it's a little different than I was expecting.
Now, it was time to start crushing it.
Yeah.
So, I just went ahead and started pressurizing it by manually cranking the handle that was on the side, and it worked exactly like a hydraulic car jack. The only difference was that it was way slower, and each time I cranked it, it looked like it barely moved the plate. However, it was also oozing out a bunch of black liquid, which I didn't really want to leak all over my press, so I quickly cleaned it up with some paper towel. I then started crushing it again, and so far, I was really happy with how it was going. Unlike with my hands, the press was doing a way better job at squishing it, and it did seem like it was a lot easier than squishing a normal piece of wood.
Can't say I know anyone that has 60,000 psi of grip strength.
So with some added pressure, these empty spaces were all supposed to start collapsing, and I think the paper again included some really interesting photos of this. This one is of course what I showed before, and this was hopefully how my wood currently looked on the microscopic scale. This, on the other hand, is what I was trying to do to it, and again, there was a massive difference. All of the empty space was pretty much completely gone, and all of those cellulose tubes had been completely flattened. On top of that, the flattened tubes had also become intertwined with all of the other flat tubes. And this was supposed to greatly increase its strength.
Yes.
But anyway, I then just continued crushing the wood, hoping that it would eventually end up like the second photo.
Be like,
and at first,
intertwining, like the sort of like making an alloy if that were a thing with biomass. One thing a lot of environmental people bring up is just use of biomass as an energy source, and I've never really understood why. I mean, I guess you could use waste wood products and use it to make energy, even though if you were just going to throw it away anyway, might as well burn the wood for energy, but it's not really any cleaner than coal, at least on the production side of things. No, you're not mining wood. It still produces a significant amount of greenhouse gas emissions, though it is renewable. So I kind of see it as an example of just because it's renewable doesn't mean it's environmentally friendly. I mean, every source of energy nuclear included, has its drawbacks. It's just something you gotta weigh for what's the most environmentally friendly. A lot of people kind of throw biomass in the same lump of renewables with, say, wind and solar, when I'd just put it in a different category.
The only issue that I had was that when it got to around half the thickness, it seemed like something bad was happening at the top.
It's getting
looked
darker.
Like some of the wood was rolling over onto itself, and I was a bit worried that it might be breaking or something. So I just kept on going, and the goal was to get it to around 20% of the original thickness, and I eventually got there a few minutes later. At this point, it was almost shockingly thin, and even though I'd squished it myself, I still kind of found it hard to believe that this used to be an entire block of wood. Besides just being super thin, though, the pressure on the wood was also around the 725 psi that the paper had called for, and I was apparently done crushing it. So now, what I had to do next was just leave it like this, and all of the water that was still left in the wood was supposed to slowly get boiled out. At the same time, though, the heat and the pressure were also supposed to cause the wood itself to slowly get stronger. This because, according to the paper, all of those flattened and intertwined cellulose tubes should start to form bonds within themselves and with their neighboring flat tubes.
So I'm trying to think of how this would affect the wood in terms of its radiation absorbing capabilities. As far as alphas and betas, short range, probably not really much of a change considering how big that block of wood was, assuming you're not dealing with any exotic accelerated alpha or beta particles. As far as gammas, well, it's thinner because it's more densely packed together. I would say its ability to absorb gammas has gone up. Granted, this is still very thin. Normally, for a typical gamma source, so not your crazy high energy stuff, you need a few inches of lead, up to maybe 8 inches of lead before it attenuates and stops a lot of it. So a lot of it's still gonna go straight through this block of wood, but it's probably gonna do a little better. Even though it's smaller, it's crushed together, you need that densely packed material. But it's lost its ability to absorb neutrons if you're boiling away the water, though, because that's really what the wood had going for it compared to other similarly thick types of material, so that's gone out the window.
All of these bonds were technically only weak hydrogen bonds, but because all of the cellulose was so closely packed together, it should be able to form a ridiculous amount of them. It was supposed to be enough to greatly increase the strength of the wood, and more importantly, to permanently lock it in its crushed form. This would make it very different than normal wood, which would just decompress once the pressure was gone, and I was very curious to see how it would turn out.
It should also improve the ductility of it, so it'll be less capable of just snapping like you imagine, most pieces of wood just snapping brittly. The martial arts experts might be a little bit more challenging for them to break these kind of boards. Or not. I'm not a martial arts expert. I do have a black belt, but it's in Lean Six Sigma, so that doesn't really apply there.
Though, I then just had to let it cook like this for the next 24 hours, and when I came back to it, it looked like it had become even thinner, and I started getting pretty excited. It was now time to reveal my densified and hopefully bulletproof wood, and when I felt that I was ready, I started lifting the upper plate. I was really hoping to see a perfect little flat rectangle, but I was immediately disappointed. I mean, it was definitely flat, which I was happy about, except it was also very wide, which wasn't a good sign.
Okay, yeah.
There had clearly been some sort of smushing effect, because the wood wasn't really supposed to spread out at all, and this was a bit sad to see. Either way, I then went to take it off the press, and the moment that I touched it, all of my sadness quickly vanished. This because it felt completely different than I expected, and it really didn't even feel like it was wood. Instead, it was surprisingly heavy and extremely hard, almost like some sort of ceramic.
I was gonna say it.
At the same time, though,
it's got the same, like the way he moves it with his hand, and even it's got that little sheen that you see from a ceramic. Still is gonna have that brittle issue. It might even be more of an issue now. I guess that is something you have to think about with hardness.
It somehow also kind of felt like plastic, and it was genuinely really cool.
Oh, maybe not then.
At the same time, though, it was definitely far from perfect, and just by looking at it, I could see that the fibers didn't get squished down properly. When I looked at it from the side, I could also see some very obvious diagonal cracks, and I was really hoping they were just superficial.
It looks like a slice of bread if it was made out of ceramic or plastic or something.
I then compared it to the piece of wood that it came from.
Wow.
And it was kind of surprising to see how different it was.
That's so cool.
In theory, it probably should have been a little less different and had roughly the same width, but still. I thought it was really impressive to see just how much thinner it had become, and I found it hard to believe that this entire block had been squished to this thin little piece. So it was, of course, at this exact moment that it decided to spontaneously fall apart.
Okay, yeah.
This was extremely sad to say the least, and it didn't inspire a lot of hope, but that all changed when I tried stabbing it with a screwdriver. I then just kept on stabbing it, and I was honestly really impressed by just how little damage it was doing. To really test it, though, I felt that I had to try stabbing it as hard as I could, and it was still really impressive. What wasn't impressive was my aim, but either way, not only was the screwdriver completely unable to stab into it, it also seemed like it had a hard time even scratching it. This was obviously not a perfect emulation of what would happen if a bullet hit it, but it was looking really promising. Just as a comparison,
you gotta start with a lower scale test and then scale up to it, though. I really like his process in this project.
I then did the same thing to one of the untreated pieces of wood, and the difference was pretty obvious. The screwdriver was easily able to stab into it, and I didn't even have to use much force at all.
Great improvement over the control.
I was now feeling a lot more hopeful about my little...
I do like that he kept his control piece of wood there to compare it to. That's very important. It's important to know where your starting point is and where you're going.
Densified piece of wood, and the only thing that I had to do next was see if it could actually stop a bullet. So, I quickly made this little wood thing to mount it to, and I clamped it in a vise. I then quickly added one of my pieces of densified wood, and with it securely in place, I went and got my gun, which was actually just a pellet gun. This is not only because firing a real gun inside my building is both super dangerous and a felony, it was also because it made way more sense to start small.
Yes.
I had to first make sure that it could actually stop a projectile, and if it did, I could then move up to the more powerful stuff. With that being said, though, the pellet gun was now loaded, and after a few days of work, I was ready for the first real test.
Cool.
So I carefully lined it up and gently started pulling on the trigger, and I was really hoping to see the pellet just get deflected like the screwdriver.
1, 2, 3.
However, that wasn't at all what happened, and it was almost comical how bad it was. The high-speed footage that I got was also completely pointless, and I was kind of embarrassed that I had even set it up. I then looked at the footage from the camera that was pointing at the back of it, and it had apparently just exploded. It really didn't look like it had even attempted to stop the pellet, and this was honestly pretty sad to see, especially after spending thousands of dollars and waiting for months to try this. What also made it even sadder was that this pellet gun was over 16 times weaker than one of the weakest real guns. So, it wasn't even remotely close to being able to stop a real bullet, and at this point, things weren't exactly looking good. So, I figured that all I had to do was somehow make it stronger and stop it from exploding, and I had some ideas that I really thought would work. Either way, I then jumped right back into it, and the first, very sophisticated thing that I'd been waiting to try was to just use a much bigger piece of wood. Seriously, though, this was a very simple change, but I really felt that it would make a huge difference, and I'll explain why in a bit.
Or you could just see how many pieces of wood like that you can line up that it would take, but that might actually take more time, having to use the press on all those individual pieces of wood, so maybe starting with the bigger piece of wood is the best choice.
With that being said, the first thing that I was going to have to do was treat it, and I did pretty much the exact same thing as before, because I didn't think anything really went wrong with this chemical step. This way, it would stay fully submerged the entire time.
Okay, this one's fully submerged.
And
all right.
after heating it for 7 hours, the solution had turned almost black. I then quickly took everything apart, carefully took out the wood and washed it to get rid of the chemicals, and again, after 15 hours of work, I was left with a wet block of wood. It looked and felt pretty much exactly the same as the first attempt, and the only difference was that it was bigger, and I loaded it into the hydraulic press. This time, though, I oriented it with the end grain facing the camera, and from this point on, things were going to be pretty different.
Maybe use one that's as big that takes up the entire room of the hydraulic press.
Because it was pretty clear to me that this pressing step was the major problem, and I actually had a bunch of things that I wanted to try. The first was to do my absolute best to center it perfectly on the plate, and I'd made some markings to show me exactly where to put it. I would also use a ruler to confirm the final placement of it, and this was very different than last time, where I just centered it entirely by eye. With the wood in place, though, I then started lowering the upper plate, and this was now the moment that I was hoping the bigger piece would start to be useful. This is because, with its much larger surface area, there would now be a lot more space for the upper plate to sit on, and in theory, this should help keep it level. This was something that never even occurred to me during the first attempt, because I thought the upper plate was fixed in place, but I discovered later on that it was apparently able to tilt.
Oh,
I also
okay.
noticed that this was happening when I closely rewatched the footage, and I saw a very subtle but clear tilt right before things started going wrong. It was only an extremely small shift, and it was probably less than a couple degrees, but crushing the wood on even a slight angle would be really bad because it would force it to get pushed to one side, and this would almost definitely cause it to smear out.
Anything involving a critical lift has to have individuals that are performing as well as spotters, a safety advocate, safety watch, for lack of a better word, to make sure that nothing changes what the initial conditions were. And if it does, then we just stop, take a break, reassess, measure, adjust if necessary, and then continue. There's a reason why a lot of those additional controls are in place.
On top of this, though, I also decided to not preheat the plates to 100 degrees Celsius and to try squishing the wood much more slowly. I figured this would give the water a lot more time to get pushed out and avoid any weird internal pressure from building up and potentially damaging the wood, and so far, things were going pretty well. It looked like it was basically just getting thinner.
I guess in this case, there'd be less thermal pressure being exerted.
And that was exactly what I was hoping for. As I kept going, though,
it's bleeding
it
and
unfortunately
oozing.
started to spread out at the bottom, and it didn't seem like I could do anything to stop it. Going even slower didn't seem to do much either, and when I looked over at the side of it, I saw something horrible. It had also started to roll over onto itself, just like the first time, but it didn't seem nearly as severe, and I figured that it was probably okay. So I just kept on going, and eventually it seemed like the wood had hit its limit, and instead of getting denser, it was just squishing out on the side. I then came back to it 24 hours later, and I was really curious to know how it turned out. I wasn't immediately disappointed.
Jumbo wood pancake.
Still really hot, but looks pretty good. I mean, it definitely still had a bunch of issues, and it had those diagonal cracks like before, but what I thought was really exciting was the other side of it, which was honestly kind of perfect.
Now it looks kind of like those laminated floor tiles that a lot of people are getting now instead of having the real hardwood. I am one of those people. I don't like having the additional maintenance associated with real hardwood.
It didn't look like there were any cracks at all, and the top part was also really nice. It was actually very similar to the original pine that I'd started with, and it didn't have a weird-looking texture or any gaps between the fibers. To know if it were actually better, though, and not just a nicer-looking piece of crap, I was gonna have to shoot it. So I got my pellet gun again, and I figured I'd blast...
I love his voice and how deadpan he is with some of these deliveries. NileRed is an absolute legend.
the ugly side first, and I was kind of expecting it to just explode like last time. However,
Ooh.
it was instead just deflected, and it hit me in the head, and I was genuinely really surprised. There was clearly a significant improvement, and even on the crappy part, it only made a small dent before getting completely flattened. And I thought that it was really cool. I decided to shoot it a few more times, and each time it was bounced away with ease.
Nice.
So apparently,
repeatable
just
results.
by swishing it better, I had made it way stronger, and my pellet gun wasn't even a challenge anymore.
Now, would I want to use this as radiation shielding? Nah. And it's mainly because the alternatives are still more cost-effective, such as using bricks of lead for gamma radiation. That would be the real improvement over this compared to regular wood would be for gamma radiation. Water's a lot cheaper for neutron shielding. And of course, concrete for your massive structure. But it is a cool idea, and to say this could stop radiation is absolutely true.
This is because my pellet gun was only shooting 22 caliber pellets, which weighed less than a gram, and they were only going around 500 feet per second. On the other hand, though, this is the equivalent 22 caliber real bullet, the 22 LR,
Sure.
And it weighs over twice the amount and goes almost triple the speed. In theory, this means that it should be able to deliver over 16 times more energy than the pellet, and I really didn't think my piece of wood could take that.
Yeah, that makes sense, with kinetic energy being proportional to the velocity squared and directly proportional to the mass. Yeah, you speed it up, it's gonna get crazy fast. It's gonna be a lot of energy. What's interesting is for looking at certain particles, you actually have to use the full kinetic energy formula for particles traveling inside of a nuclear reactor, because there you're going at relativistic speeds. And that is where the blue Cherenkov glow comes from, is having particles traveling faster than light and water. We don't have any bullets that fast, though. Not even one's getting shot out of a railgun. Ooh, does he have a railgun? I don't know if we'll get to that level of testing.
I mean, maybe it could have done something that was double or triple, but over 16 times was just insane. For some reason, though, I still had faith that this wood could do it, but I was for sure going to have to somehow strengthen it even more.
Put a few more slices together.
In my mind, there was also only one real way to do this, and I was going to have to somehow stop it from spreading out. If I were able to do this, this should not only give me something that was significantly denser and way stronger, it should also just be higher quality in general, and without any of those diagonal cracks. I really thought that it would be enough to stop at least the 22 LR, and again, I had some ideas that I thought would work. I was really starting to think that maybe pine actually just sucked, and that it was too soft to hold its shape, so as a completely last-ditch effort, I tried switching to oak, which was a hardwood. However, this again didn't seem to make any real difference, and the wood was still just getting squished out. When I saw this, I honestly just kind of felt like quitting, but at the same time, I was starting to think that it was really odd that the paper didn't mention anything about this. I also suddenly realized that they only showed cartoon versions of their press, and this made me start to think that this whole time, they might have been secretly using more than just a simple press. I mean, I have no idea if that's actually true, but I felt that they had to be using something to physically stop it from spreading out, and after 30 minutes of having no idea what I was doing in Fusion 360, I was able to design these two pieces. I then sent them to a machining company, and after a few weeks, I was the proud owner of this hunk of stainless steel. I would add this other hunk of stainless steel. I could then load this entire thing into my hydraulic press, and now it would be impossible for the wood to squish out on the sides.
Barring it somehow deforming the metal. Yes. That's awesome.
And there was no way that this could fail. Carefully loaded it into my new template. Then on top of it, I added the huge metal block, and now I had to load this entire thing into my press. To do this, I just carefully slid it in, and I did my best to line up all of the edges. This way, it would be perfectly centered in the middle of the plates, and when I felt that it looked good, I lowered down the top plate. This time, I didn't have to worry at all about it squishing out to the sides, and I was also able to go way faster, and this was 1,000,000 times better than anything I was doing before. Also,
Look at it
just
push
based
on those
the amount of
sides.
water that was coming out, I felt that there was no way that the inside of the wood wasn't treated. In total, I was able to collect a few hundred mils, which to me was way too much if it was just coming from the outer part of the wood, but
Sure.
who knows? Either way, it was eventually done, and over the next few hours, I went back to it every 20 minutes to repressurize it. This wasn't something I'd done in the earlier runs, but from all my failed attempts, I had learned that it was important. This is because as the water boiled out of the wood itself slowly shrank, and the pressure on it gradually decreased. So, if I wanted to maintain the high pressure that was needed, I had to keep coming back to it until pretty much all the water was gone, and then I left it for 24 hours.
Oh, I didn't realize he wasn't doing that, because anything, especially a phase change, is going to exert a force. It's coming out as the water leaves, so that's going to be your mismatch in force. So yeah, just getting your pressure back up to what it was makes a lot of sense.
When I eventually came back to it the next day, I was really curious to see what it was like, and all I had to do next was open it up. Inside of it was a beautiful piece of densified wood, and it really was by far the best result I had ever gotten. That looks really good.
Beautiful.
Considering that it also didn't push any of its volume out to the side, this meant that it was significantly denser, and overall, it just felt way stronger and more durable. It was time to see if this could actually stop a real bullet.
That takes some cojones right there.
I was able to legally borrow a .22 rifle from my friend, and I drove very far away to where it wouldn't be a felony to shoot it. And it was time to put the wood in place. To do this, I decided to go with a very sophisticated method, and I just gorilla taped it to a large styrofoam block. Evan then wedged a stick behind it to prevent it from tipping back, and at this point, I was finally ready for the first real test. The only challenge now was that I had to actually have decent aim and hit the wood, and also not destroy my cameras, which were uncomfortably close. Either way, though, with all
not shooting
this in
point
mind,
blank is probably a good idea.
With a single .22 LR bullet, and it was finally time to see if all this work was worth it. And then I quickly ran to stop the high-speed camera.
There you go.
The moment I got closer, though, I was immediately concerned by what I saw. I then quickly got rid of the gun that I probably shouldn't have been running with, and I went back to take a closer look. So, looks like there's a hole. Right there.
Uh-oh.
And, there's a hole on the back, too.
No.
I think the verdict is that it wasn't bulletproof. No!
Glad you didn't use the other test where you stand holding it in front of you like you're doing some sort of William Tell thing.
Yeah, that didn't work. Just like the very first attempt, it also kind of looked like the back of it had just exploded, and that it hadn't even stood a chance.
Yeah.
This was definitely not the result that I was hoping for, and I was genuinely
Well, guns are
feeling pretty
designed to
sad
do
about
that.
it. When I got back, though, I was able to clean it up and take a better look at it, and I realized it wasn't actually as bad as I thought. I mean, it still wasn't ideal, and the bullet had clearly gone right through it, but what was important was that it hadn't just catastrophically exploded it, and this made me feel like it wasn't actually that far off from stopping it.
Put a few of them together.
I really felt that something just slightly stronger would have been able to do it, and as one final test, I wanted to try adding a second layer. This was actually something that the paper tested, and they found that only one extra layer could make it over 5 times stronger, and I felt that this would be more than enough.
And stagger them, yeah, make it like a patchwork.
I was of course going to have to make at least a couple more pieces, and unfortunately, I had to go back to cooking and crushing wood. However, to go faster, I decided to scale up the whole cooking part, and in this large stainless steel pot, I was able to load in 4 pieces. This was way better than doing each one in, and it saved me a couple days of work. Piece was not only perfectly flat, it was also even thinner. I then ended up making a bunch of extras, just in case I needed them, and after a week of frustration, it was finally time to glue some together. But I found this stuff at Home Depot, and it claimed that it was impact resistant.
There you go.
So I decided to just go with it.
Probably wasn't tested on bullets.
The entire bottle, and I did my best to cover the whole piece.
Crisscross with the glue.
Knowing that this piece had its grain pattern going in the vertical direction, I went and got my second piece, and I carefully lowered it down with the grain going horizontally. This way, the grain patterns would not be perfectly aligned, and they'd be at 90 degrees to each other, and doing it like this was supposed to make it significantly stronger. Just for good measure, I also dropped a tungsten cube on it, and I left it to cure.
As one does.
I then went back to it 24 hours later, and I got rid of all the metal and cleaned it up, and this was the final result. What I had now was a nice block of densified wood, and just by looking...
Now that tungsten cube would be effective at stopping gamma radiation. Something nice and dense.
It also really felt like it would actually be able to stop the 22, and that it wouldn't be a pathetic failure like the other one. So I went back out to the forest, I had made a much better mounting system for the wood, and I clamped it into this metal thing. I then shoved it into a much stronger and heavier foam block, and it was time to shoot it. I then loaded the gun with one bullet, and I got ready to blast it. Again, I was really hoping that I wasn't just gonna completely miss it. And then I immediately ran to turn off the high-speed camera. Unlike the other time, though, I wasn't immediately disappointed because I didn't see the same clean hole as before. This time, it looked like the bullet had splintered the front part, and for some reason, I felt that this was a good sign.
I don't know if it went through. It went right through.
No!
Oh.
How? The moment that I saw this, I was honestly a bit frustrated because I genuinely thought this was going to work.
Are you serious?
I was also starting to think that this project might just be completely hopeless because if I couldn't even stop a 22 LR, there was no chance of making anything I could remotely call bulletproof.
Right through. Really? Oh, no. Actually, it stopped it.
Nice.
It stopped it. So the back splitting was just...
Yeah, okay.
It was just absorbing all the energy.
Yeah.
If you look how deep the bullet went, right? It looks kind of the same distance that it pushed the wood out.
One thing that I'll clarify when doing a ballistics test, that's not the right word when looking at radiation sources, but for lack of a better word, the source is basically emitting many thousands, if not millions of these per second, depending on the strength of your source. So you're evaluating counts on one side of the target versus the other. Everything involving nuclear reactions is just a big Monte Carlo simulation. So it's roughly odds of things passing through, meaning something that even your 8+ inches of lead with a gamma source, you're still going to get some counts because you're playing this game many times per second. Some of them are going to get through, just way less of it than through the equivalent distance of air, to use it as an example. So, unfortunately, NileRed doesn't have the luxury of trying something and then, I don't know, using a machine gun of sorts. 22 machine gun, not sure if that's a thing, but not a gun expert, but... So, the point is you get to see a lot more of repeatable results when doing experiments with radiation than doing a ballistics test like this.
So apparently, I just lost hope way too early, and with 2 layers of the densified wood, I had technically stopped the 22 LR. In my opinion, this was really cool, but at the same time, I didn't feel that it was quite good enough because the back still got split apart. I was actually a bit worried that this would happen though, and this was why, just in case, I had also made a 3-layered version.
Yes.
In theory, this should have been even stronger than the 2-layered one, and I felt that it would solve all my problems. However, at the same time, I also felt that this was my absolute last chance to make it work, because adding any more layers would make it way too thick. Right now, it was still thinner than just one of the untreated pieces that I had started with, and I felt that this was the absolute limit.
Sure.
If this didn't work, I'd have to come up with some other solution, or more likely, I'd probably just quit.
Okay. I think it's good.
But anyway, at this point, I was ready to test it, so I carefully aimed the gun. And this time my aim was terrible. I ended up kind of missing, which was a little bit sad, but what wasn't sad was the result. It looked like the bullet hadn't even made it past the first layer.
Glancing hit.
And just to confirm that this was real, I shot it again.
What happened?
Nice.
It just chunked it. That's all it did. Look at that. That's it. Yo.
Clean.
Not even splintered at all.
So apparently, 3 layers was significantly better than 2, and when I looked at the high speed, it looked like the 22 LR didn't even stand a chance. I mean, it totally exploded the first layer of wood, but the bullet itself was also completely destroyed, and it was bounced away as a bunch of fragments. After seeing this, I was really excited because I had finally stopped a real bullet using wood, and by definition, I had made bulletproof wood. However, it was also one of the weakest bullets possible, and when I looked up the levels of bulletproof armor, the charts didn't even go as low as 22 LR.
Why is there a level 1? Not an armor expert.
It seemed like the lowest rating was the common 9mm, which is often used in handguns, and this was the bare minimum of what many people considered bulletproof. The only scary part was that the 9mm was significantly bigger, and compared to the 22 LR, it would have around 2.5 times more energy.
Though it is thicker, though, so that thicker, it's going to be more energy dispersed on the target.
On top of that, though, it also had a copper jacket, which would give it more penetrating power, and I really didn't think my poor block of wood could stop one. However, I felt that if I actually wanted to consider what I had made bulletproof, it had to stop a 9mm, and I had thankfully borrowed another gun from my friend. This one just felt way more powerful than the other one, and I was really not feeling optimistic.
Okay. Safety off. My poor wood is just evaporating.
This time, I actually saw chunks fly off the piece of wood, and I was also kind of shocked by what I saw.
Wait.
Did it work?
Yo, it stopped it. It actually stopped it. What the? It's there. It's just flat.
Check that out.
Dude, you can see the whole bullet just flattened in there. That's cool.
So apparently, the 9mm didn't actually just destroy it, and adding that third layer had clearly made it a lot stronger.
All the difference in additional layer makes.
It was also really cool to see the bullet get almost instantly flattened and completely stopped by the second layer, and I was genuinely surprised that this happened. The only concerning part was when I looked at the back of it, and it looked like it had almost exploded.
Ooh.
It was on the verge of not making it.
Either way, though, it did stop it, and at this point, I felt that I could officially say that I had made some bulletproof wood. I mean, it was of course still far from perfect, but it was way better than anything I ever expected, and it was definitely better than the regular wood that I had started with. This was made especially clear to me when I tried shooting a huge stack of it with the same 9mm.
Okay,
and
yes.
even with 7 layers, it almost wasn't enough. And in comparison, it was kind of shockingly bad. It literally got stopped in the last one. Wow.
I was curious how regular wood was going to do against the bullet. I'm glad he showed the control method on how much regular, untreated, unpressurized wood you would need, and the answer's a lot more. That's actually also the same method we use for testing radiation shielding. Is you look at the equivalent in air, because air isn't nothing. It's going to particles can get attenuated in air, if not completely stopped with with enough of it, though. Though it ain't gonna do much against some things, such as high energy gamma ray bursts from space.
With all that being said, though, this entire project was mostly just meant to be a proof of concept and to see if wooden armor was even possible, and I guess the answer is that it is. I mean, it still definitely needs a lot of improvement, and this is not anything that I would currently want to wear, but I think that it has a lot of potential. I also think that it could be really interesting to try combining it with other materials like plastic, metal, or even Kevlar. I genuinely think that it's possible to make something that's less than half the thickness, but still easily able to stop the 9mm, and maybe even some more powerful bullets.
That's true. It can be like an enhancement plating over existing armor. One thing about Kevlar is the little weaves in the fabric can actually be weakened by UV radiation. So don't leave that sitting out in the sun. In fact, don't let any safety equipment sit out in the sun for a while. Little humble non-ionizing radiation can still have some effects.
For now, though, I think I'm tired of cooking, crushing, and shooting wood. And instead, I'm going to work on some more tasty projects, like turning styrofoam into cinnamon candy.
That was so cool. Thanks so much for all the recommendations for this video. And it is cool to see that there are some bits of overlap between ballistics and radiation protection. It's always cool to see NileRed stuff, and I love his processing. And wow, this original video was just under an hour, and I felt just enthralled the whole time. And it's like, yes, anything to... He's just very engaging in the way he does things. You don't really see that even on like TV shows and movies that are supposed to be entertaining. But hey, maybe I'm just a nerd and more into this sort of stuff. Thank you very much for watching. I'll see you next time.